Okay, in this video we're going to look at one of the less common types of convergence tests. First of all, though, I just wanted to review a couple of things, and this is a quiz for you to take, so make sure you go and answer these questions on the quiz. Of course, this is number 1, this is number 2, so just take a look here. We've got fraction, we're integrating a fraction. I guess to start with, I would probably begin thinking about partial fractions, just because, first of all, it's already given to you in a factored form, but also substitution is not going to work. Okay, so figure that one out, and then, of course, plug in 3 and 2. Next, the length of the curve, y equals x cubed from 0 to 2. So remember, we always do an integral, square root of 1 plus the derivative squared. Okay, that's our way of finding arc length. So again, pause here, get the answers, and take the quiz. All right, the root test. The root test, there's a lot of different ways you can look at it, but I think the simplest way that I've always thought is basically, let's say you have a series, okay, some series where something, some function is all raised to the nth power, okay? If that function, or if that box is less than 1, then then the entire series will converge. It's kind of an offshoot of geometric. So we call it the nth root because it essentially says if I take the nth root of that box to the n power, then all I get out is that box. And if that box is less than 1, then it converges. You'll notice it diverges if it's greater than 1, if that box, but if it's equal to 1, we have to use a different test. So again, it's called the nth root test, or the root test, because we have something being raised to the nth power. If we take the nth root of that thing, the nth root of something to the nth is just that function. If this is less than 1, then we are converging. Again, really similar to geometric, but I just want you to look at this. Okay, so now we've got an entire thing being raised to the nth power. So if I look at this and I say, well, and again, if you take the nth root of something to the n, it's just that box, so, oop. The limit is 1/2, which is less than 1, so this thing, the series converges. Okay? Now, it really, as I said, is an offshoot, kind of combining a bunch of different things along with geometric. Okay? So, like this one, we could rewrite this as 3/5 to the n. So again, this is just showing another way of doing geometric, where we say, okay, so the limit of this, silly as it is to do, because we know it's geometric, but the limit of 3/5 as n goes to infinity is 3/5, which is less than 1. So this also converges. Okay? And again, the reason it's called the root test is essentially you're ignoring the fact this function has been raised to the nth power, and by ignoring it, quote unquote ignoring it, you're essentially taking the nth root of something to the nth power. Okay? I just wanted to show 3 more examples, and some of these you could do with the root test, and maybe some would be better done with a different test. But this is the point now where we have to start making those decisions. What test is best? So with all of these powers, I don't think it would be a bad plan at all to use the ratio test. Okay, ratio, remember, works best for nth powers and factorials. Because of all these things being raised to the n, I think we could also use the nth root test, and that's what I'm going to try and do here. I'm going to rewrite this as 2 squared to the n and 3 to the n over 10 to the n. Just make sure you see 2 squared to the n is 2 to the 2n. Okay, so now I can rewrite that as 4 to the n multiplied by 3 to the n over 10 to the n. Well, 4 to the n multiplied by 3 to the n, get this, this is 12 to the n. So 12 to the n over 10 to the n, which we could rewrite as 12 tenths to the n, which is obviously a divergent geometric. Okay. Okay, let's look at this one. Okay, so I'm just using a little algebra. Okay. Remember what we talked about on the very first day of geometric series, where we always like to have the powers, the same powers. You know, that's kind of my manipulation I did up here. I said, well, I'd like them both to be to the n. So here I'm going to do the same thing. I'm going to have 4 to the n. I'm going to have 3 squared multiplied by 3 to the n, which is the same as 1/9 multiplied by 4/3 to the n. So again, what's inside here is bigger than 1, so this diverges. Now this last one, 2 to the n multiplied by n cubed over 3 to the n, for me, especially once we start mixing, you notice up here everything was exponential, so we really could treat them as either a root test, you know, where we say, oh, what's being raised to the nth power is less than 1, or greater than 1. But once we start mixing powers with polynomials or powers with factorials, then I might think ratio test. So let me do that. Let me do a limit as n approaches infinity. And remember, we always do the next term divided by the current term. Okay, in the interest of space, let me just bring this up. We're going to multiply by the reciprocal. Okay, or that. Let's do a little simplifying. Okay, 3 to the n divided by 3 to the n plus 1 is just a 3 in the denominator. Oh, I forgot my 2 to the n here. Okay, 2 to the n plus 1 divided by 2 to the n. It's just 2 in the numerator. So I end up, right here, what I've got left, I've got an n plus 1 cubed and a 2. And in the denominator, I have a 3 and an n cubed. Well, if I multiplied this whole thing out, I'd have, you know, n cubed as my largest power, so I'd have 2n cubed plus blah, 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 blah. And on the bottom, I'd have 3n cubed, which if I'm doing the limit as n goes to infinity, is 2/3, which is less than 1. So this converges. Remember, the ratio test, to prove convergence, we need the ratio of the next term and the current term to be less than 1. Okay, so again, the root test is really, you know, when you see some function being raised to the nth power, you really kind of ignore the nth power. You take the nth root so that you ignore it, and you just check the limit of what's inside. And if the limit of that function being raised to the nth power, the limit of just that function is less than 1, the series converges. If it's greater than 1, it diverges. Remember, if it's equal to 1, we have to do something else. And then, as I said, you get a couple examples here of different tests we can use. Some root, some geometric series, and some ratio test.